What if the world you've lived in your entire life still hides truths that no textbook, no documentary, and no classroom ever dared to reveal? We look at Earth every single day. Its skies above, the ground beneath, the oceans stretching endlessly. But how often do we stop to wonder what's actually going on beneath the surface or behind the stories we've been told? From the earliest myths carved into stone tablets to the most advanced scientific theories published today, humanity has always tried to explain Earth's mysteries. But the more we learn, the stranger the picture becomes. It's almost as if the planet itself is guarding secrets, revealing just enough to keep us hooked while concealing the rest. Think about this. We've explored outer space more than we've explored our own oceans. Let that sink in. Vast portions of our planet are still uncharted, untouched, and cloaked in mystery. Scientists admit we know less about Earth's molten core than we do about the surface of Mars. Entire landscapes remain hidden beneath ice, deserts and seas, waiting to be uncovered. And as we peel back these layers, what we find often challenges everything we thought we knew. Strange sounds in the deep ocean, unexplained flashes in the sky, sudden sinkholes swallowing entire neighborhoods. Each discovery leaves behind more questions than answers. And then there are the whispers, the stories that science can't quite disprove, the ones that spark conspiracy theories and keep people debating late into the night. Could lost civilizations lie buried beneath the sea? Are governments hiding knowledge of global threats, choosing secrecy over panic? Are we living on a planet that's still far more mysterious, more dangerous, and more extraordinary than we dare to imagine? This isn't just another story about Earth. This is the story of the unknown, the untold, and the unbelievable. By the end of this journey, you might see the world around you different. And here's the real question. Are you ready to uncover the secrets that our planet has been keeping from us all along? Every story has a beginning, and when it comes to Earth, that beginning is far stranger and more mysterious than most people realize. Textbooks often simplify it. About 4.5 billion years ago, dust and gas swirled in space, clumping together under gravity until a planet was born. It sounds neat, tidy, and almost comforting, like the world we stand on was always destined to form exactly as it did. But when you dig deeper into what scientists have uncovered, and when you also consider the myths and unexplained theories humanity has carried for thousands of years, the origin of Earth begins to look more like a puzzle with missing pieces than a finished story. Modern science tells us that Earth formed from violent collisions, giant rocks and fragments of early solar debris smashed together again and again, releasing unimaginable heat until the surface melted into a glowing ball of magma. It wasn't peaceful, it was chaos, destruction and fire. Out of this cosmic violence, our planet somehow stabilized, cooled, and eventually became the blue and green world we know today. But even here, there are gaps. One of the greatest mysteries lies in something called the giant impact hypothesis, which suggests that a planet-sized body, often nicknamed Theia, crashed into Earth billions of years ago. From the debris of that collision, the moon was formed. But here's where it gets strange. Scientists can't fully explain why Earth and the moon share such eerily similar isotopic fingerprints. It's as if they were made from the exact same material, raising questions about whether the moon was always a part of Earth, or whether something else happened that we still can't grasp. Now compare that with the myths of ancient civilizations. Across cultures, from the Sumerians to the Greeks, from Hindu epics to Native American legends, there are stories of Earth's birth tied to divine battles, cosmic eggs, or deities tearing each other apart to form the world. On the surface, these myths might seem like symbolic tales meant to explain the unknown. But when you hold them next to the scientific theory of a violent impact shaping Earth, the parallels become eerie. The ancient idea of gods clashing in the heavens sounds remarkably like the giant impact theory, suggesting that perhaps our ancestors knew more or witnessed more than we give them credit for. Could oral traditions have preserved echoes of real cosmic events that shaped Earth's early history? But that isn't where the speculation ends. Some alternative theorists have proposed that Earth's origins might not be as simple as dust and gas forming a planet. Instead, they argue that Earth shows signs of being seeded with life early, maybe even earlier than traditional timelines allow. This theory, often tied to the concept of panspermia, suggests that life's building blocks may have arrived from space, hitching a ride on asteroids or comets. That would mean Earth wasn't entirely self-made. It was jump-started by something beyond our planet, possibly even beyond our solar system. If that's the case, then life on Earth might share roots with life elsewhere in the universe. It's a concept that pushes the boundaries of imagination and makes Earth's beginning feel less like a solitary accident and more like part of a larger cosmic plan. And then there are the more controversial whispers. The Hollow Earth theory, the claims of advanced civilizations predating history, and the suggestion that ancient beings could have had knowledge of Earth's structure long before science caught up. While mainstream geology dismisses these ideas as fringe or pseudoscience, the persistence of these beliefs across cultures keeps them alive in popular imagination. Why do so many legends speak of worlds beneath our feet, hidden realms or inner suns? Could they be symbolic stories, or could they stem from some forgotten knowledge of Earth's early mysteries that has been lost to time? Even in modern science, there are lingering uncertainties. We say Earth is 4.5 billion years old, but how exact is that number? Dating relies on meteorites and radioactive decay, but with discoveries of rocks that defy expected timelines, the picture sometimes becomes blurred. There are also anomalies in Earth's composition. For instance, certain metals exist in greater abundance than models predict, leading some scientists to wonder whether Earth received these materials from extraordinary events, like collisions with rare metal-rich asteroids that altered its destiny forever. But perhaps the most unsettling part of Earth's origins is the realization of how fragile it all was. A tiny difference in conditions, slightly closer to the Sun, a slightly weaker magnetic field, a missing collision could have meant no life at all. Earth seems finely tuned, balanced in ways that leave room for speculation. Was it pure chance, or was there something more guiding the formation of this planet? Religious traditions point to divine creation, while some modern scientists toy with the idea of a fine-tuned universe, where conditions appear suspiciously perfect for life. It's a debate that stretches from laboratories to temples, from science journals to late-night conspiracy forums, and it all starts with the same question: how did Earth begin? The truth is that Earth's origins remain a riddle. Science provides frameworks, myths provide stories, and speculation fills the gaps between. But what all these perspectives agree on is this: Earth's birth was anything but ordinary. It was violent, it was strange, and it was filled with twists that still baffle us. And maybe that's the most fascinating part. Our planet's beginning isn't a closed book. It's a mystery still unfolding, one that forces us to rethink everything we thought we knew about the very ground we walk on. But if Earth's origins are still filled with unanswered questions, what about its hidden heart, the core that lies beneath us, unreachable and unseen? Scientists admit we know less about the center of our planet than we do about outer space. And what they've found so far only deepens the mystery. Beneath our feet lies a world no human will ever see, a place more alien than the surface of Mars and more mysterious than the deepest ocean trench. I'm talking about Earth's core, the hidden engine that powers everything from the magnetic field that shields us from deadly cosmic radiation to the volcanic eruptions that reshape continents. It's a place we cannot drill to, cannot visit, and cannot directly measure. In fact, scientists openly admit we know far less about the Earth's core than we do about outer space. Think about that for a moment. Our telescopes can map galaxies billions of light years away, yet the world beneath our very feet remains a shadowed unknown. And what we have discovered so far is strange enough to rival science fiction. At its simplest description, the Earth's core is split into two parts: the liquid outer core and the solid inner core. The outer core is a swirling ocean of molten iron and nickel, hotter than the surface of the Sun. Its constant movement generates Earth's magnetic field, the invisible shield that protects all life from solar winds and cosmic radiation. Without this, our atmosphere would be stripped away, and Earth would be as lifeless as Mars. But here's where the mystery begins. The inner core, sitting at the center, is thought to be a solid sphere made mostly of iron. But recently, seismic studies, waves from earthquakes traveling through Earth have suggested that the inner core might not be uniformly solid. Some data points to strange layers within it, or even a core within the core, with properties unlike anything we've imagined. It's as though the Earth is hiding nested secrets, layer upon layer, each one more puzzling than the last. And then there's the rotation problem. For decades, scientists believed that the inner core spun slightly faster than the rest of the planet, a phenomenon called superrotation. But new evidence suggests the inner core may actually be slowing down, or even reversing relative to the mantle. If true, this could mean massive changes in the behavior of Earth's magnetic field. A weakening or reversal of the field could have devastating consequences for life as we know it, from disrupting navigation systems to exposing us to harmful radiation. While scientists caution against panic, the fact remains, the core is unpredictable, and its behavior is something we don't fully understand. Of course, where science hesitates, speculation rushes in. Some alternative theories claim that the core may not be entirely solid at all, or that it might house something far stranger than iron and nickel. The hollow earth theory, long dismissed as pseudoscience, continues to capture the imagination. According to its believers, vast caverns or even entire inner worlds exist beneath us, with entrances hidden at the poles or deep within mountain ranges. Legends from Norse mythology, Tibetan Buddhism, and Native American traditions speak of underground realms inhabited by advanced beings or lost civilizations. Could these stories be symbolic echoes of our ancestors' attempts to explain the unseen, or could they hint at truths hidden beneath the surface? Even mainstream science leaves room for wonder. Seismic data has revealed anomalies in the lower mantle, regions where waves slow down or behave unpredictably, as if passing through strange materials. Some scientists believe these could be remnants of ancient planetary bodies that collided with Earth, now buried deep inside. Imagine that, pieces of alien worlds locked forever in our planet's hidden heart. Others speculate that exotic forms of matter like crystals of iron at pressures beyond human comprehension could exist there. If so, the core is not just a fiery ball of metal, it's a laboratory of the impossible, creating substances that defy what we know of chemistry and physics. There's also the question of heat. The core is unbelievably hot. Estimates range from 9,000 to 11,000 degrees Fahrenheit. But scientists still don't fully understand how it has remained so active for billions of years. Radioactive decay contributes, but is it enough to explain the energy output we observe? Some have suggested that unknown processes could be at play, ones we haven't yet identified. It raises the unsettling possibility that Earth's core might not be as stable as we think. Could its heat engine eventually sputter out, leaving us without the magnetic field that makes life possible? Or could sudden changes in the core trigger catastrophic shifts in Earth's geology and climate? Then come the rumors, the claims that governments and agencies like NASA know more about Earth's interior than they admit. There are stories of strange vibrations recorded deep underground, unexplained booms heard across the globe, or even classified drilling projects cut short after encountering something unexpected. While evidence is scarce and often speculative, the persistence of these claims suggests a collective suspicion that something about Earth's hidden core doesn't add up. One of the most dramatic fears tied to the core is the idea of a magnetic pole reversal. Geological records show that Earth's poles have flipped many times throughout history, with north becoming south and vice versa. The last reversal happened about 780,000 years ago, and scientists say we may be overdue for another. Already the magnetic field is weakening in certain areas, particularly over the South Atlantic. Could this be the beginning of a shift? And if so, what would it mean for modern society, so dependent on satellites, power grids and global communication? For our ancestors, such a shift might have been nothing more than a curiosity. For us, it could be chaos. At the heart of it all lies one truth. The core remains untouchable, unreachable. We can send robots to Mars, but we can't send a probe to the center of our own planet. The deepest hole humans have ever drilled, the Kola superdeep borehole in Russia, barely scratched 7.5 miles down, a fraction of the journey to the core. Beyond that point, the heat and pressure are simply too extreme. Everything we know about the core comes in directly through sound waves, models, and educated guesses. And guesses, no matter how informed, always leave room for mystery. So what should we make of this unseen world beneath us? Is it simply a churning ball of molten iron and nickel, or does it hold secrets that could rewrite our understanding of Earth and perhaps even our place in the universe? One thing is certain, the deeper we look, the stranger it gets. And while science continues to probe the mysteries of Earth's heart, the core remains a place of endless speculation, a reminder that the greatest unknowns don't always lie in the stars above, but in the ground beneath our feet. But the mysteries don't stop there. If we've barely scratched the surface of the core, what about the vast oceans covering more than 2/3 of our planet? We've mapped the moon more thoroughly than our own seafloor, and what hides in those depths may be even more shocking. When most people think of the unknown, their minds immediately wander to outer space, the infinite stars, the distant planets, the black holes swallowing light itself. But here's the twist. The greatest frontier of mystery isn't light years away. It's right here on Earth, lapping against our shores, stretching endlessly across the horizon. The oceans cover more than 70% of our planet, yet over 80% of their depths remain unexplored. That means most of Earth's underwater world is still a blank page in humanity's book of knowledge. We know more about the craters on the Moon and the weather on Jupiter than we do about what lies beneath the waves of our own planet, and that fact alone should make you wonder what secrets are hiding in the deep. The ocean isn't just water, it's a realm of extremes, crushing pressures that could flatten a submarine, pitch black darkness where sunlight has never penetrated, and temperatures so cold they would freeze any unprotected life. And yet, life thrives there. Scientists have found bizarre creatures that defy our expectations, fish with transparent heads, squid longer than buses, glowing organisms that create their own light. The deep sea is like an alien world, but one we barely understand. And if these are just the creatures we've managed to glimpse, imagine what might still be lurking in the 80% we've never seen. Take the Mariana Trench, for example, the deepest point on Earth. Plunging nearly 36,000 feet below the surface, only a handful of human expeditions have ever reached its bottom. One explorer described it as an alien landscape, with strange organisms clinging to the rocks and fluids seeping from the seafloor. Some recordings from the trench captured eerie, unidentifiable sounds, groans, whistles, and metallic bangs that scientists struggled to explain. Were they geological movements or something else entirely? The ocean has a way of holding on to its mysteries, giving us just enough to spark curiosity but never enough to satisfy it. And then there's the bloop. In 1997, hydrophones underwater microphones recorded an ultra-low frequency sound in the South Pacific. It was so loud it could be heard across 3,000 miles of ocean. At first, scientists were baffled. The sound didn't match known animals, ships, or geological events. Some even speculated it could have been produced by a creature larger than any whale ever discovered. Later explanations suggested shifting icebergs. But even today, not everyone is convinced. The bloop remains a reminder that the ocean is filled with noises, signals, and movements we still don't understand. Legends of the sea have always fed off this uncertainty. From ancient sailors telling stories of sea serpents to modern conspiracy theories about underwater civilizations, the ocean has long been a canvas for human imagination. The idea of Atlantis, a lost city swallowed by the waves, persists in popular culture, while mainstream historians dismiss it as myths. Discoveries of sunken ruins in places like Yonaguni, Japan, or Dwarka, India, raise questions. Were there advanced civilizations that lived along coastlines now buried by rising seas? Could remnants of human history be lying in silence beneath the ocean, waiting to be uncovered? And it's not just myths of civilizations. There are persistent rumors of unidentified submerged objects, or USOs, spotted by naval officers and fishermen alike. These aren't just ordinary sightings of strange shapes in the water. Some reports describe glowing objects moving at impossible speeds, diving from the sky into the sea without making a splash, or vanishing into the depths with no trace. Even declassified military documents acknowledge unusual underwater phenomena that defy explanation. If the skies have UFOs, could the oceans be hiding their counterparts? What makes the mystery even more unsettling is how little control we actually have over the ocean. Storms, tsunamis, rogue waves, all can rise without warning, reminding us that the sea doesn't answer to us. Even with modern technology, entire ships vanish without explanation. The Bermuda Triangle, infamous for strange disappearances, continues to fascinate and terrify. While skeptics blame storms, human error, or methane gas bubbles, the sheer number of odd vanishings keeps the legend alive. Could the oceans themselves hold anomalies, magnetic fields, hidden currents, or even something supernatural that play a role in these unsolved mysteries? The economic and political dimensions add yet another layer. Nations compete for control of underwater resources, oil, minerals, and fisheries, yet they're competing over areas they barely understand. Deep-sea mining operations have already begun scraping the ocean floor, stirring concerns among scientists who warn that disturbing ecosystems we don't even fully know exist could have unforeseen consequences. Some even suggest that powerful corporations or governments might already be sitting on discoveries, rare materials, biological breakthroughs, or evidence of ancient ruins that they've chosen to keep hidden. After all, information is power. And what better place to bury secrets than in the ocean depths? Then there's climate change, which is quietly reshaping the seas. Melting glaciers are raising water levels, swallowing coastlines and uncovering landscapes long hidden under ice. Warmer oceans are producing stronger storms, and changing currents are altering ecosystems. But these shifts may also reveal surprises: ancient artifacts thawing out of glaciers, undiscovered species forced into shallower waters, or even long-forgotten wrecks rising closer to the surface. The ocean in its restlessness is not just hiding mysteries, it may one day deliver them to us whether we're ready or not. One of the strangest aspects of the deep sea is how it connects to human psychology. Unlike space, which we gaze at with wonder, the ocean inspires unease. It's vast, it's dark, and it's indifferent to us. This is why it so often shows up in horror stories, from monstrous leviathans to haunted shipwrecks. The fear is primal, the fear of the unknown, of being swallowed by a force we cannot fight. Yet it's that same fear that makes the ocean so captivating. We know it's dangerous, but we can't look away. So what do we truly know about Earth's oceans? Very little. We've mapped only fragments, encountered only glimpses of what's down there, and explained only a handful of its strangest events. Every new expedition seems to reveal something bizarre, a creature that looks like it belongs in another world, a sound that defies explanation, a shipwreck carrying secrets of history. And if this is what we've found so far in the small fraction we've explored, just imagine what's still waiting in the dark. The oceans are more than just Earth's largest feature. They are Earth's largest question mark. And as long as the majority of them remain unexplored, they will continue to feed myths, conspiracies, and legitimate scientific wonder alike. The truth could be anything: alien life hiding in the depths, remnants of forgotten civilizations, or simply natural phenomena we haven't yet learned to interpret. But one thing is clear: the ocean keeps its secrets well. And if the seas hide so many enigmas in their depths, what about the very sky above us? The atmosphere that surrounds Earth may seem ordinary, but it carries its own mysteries, shields, holes, and phenomena that remind us the unseen is often just as powerful as what we can see. When you look up at the sky, it seems so familiar. Blue during the day, black and star-filled at night. We breathe it, we live under it, and we often take it for granted. But the truth is, Earth's atmosphere isn't just a passive blanket of air surrounding us. It's a complex, layered system filled with mysteries, anomalies, and phenomena that scientists still struggle to explain. Some of its secrets are beautiful, like the shimmering auroras near the poles. Others are terrifying, like sudden bursts of radiation, or strange holes in the ozone that leave parts of our world dangerously exposed. And then there are the unexplained events, flashes of light, strange sounds from the sky, and weather patterns that defy logic, phenomena that keep reminding us that our own skies may be just as mysterious as the deepest ocean trenches. The atmosphere is divided into layers: the troposphere, where all weather occurs; the stratosphere, home to the ozone layer; the mesosphere, where meteors burn up; the thermosphere, where auroras dance; and the exosphere, the thin veil that merges with space. Each of these layers plays a role in protecting us, yet each also hides phenomena we barely understand. Take the ozone layer, for example. For decades, scientists believed it was a stable shield against harmful ultraviolet rays from the sun. But in the 1980s, they discovered massive holes forming, especially over Antarctica. These holes weren't natural. They were caused by human-made chemicals like chlorofluorocarbon. For years, the world scrambled to repair the damage, and while international efforts have reduced the destruction, new fluctuations continue to appear, reminding us of how fragile this invisible shield truly is. But ozone holes are only one part of the mystery. There are also phenomena like sprites, jets, and elves. Names that sound like something from mythology, but are actually bizarre electrical discharges that shoot upward from thunderstorms. Unlike lightning, which strikes downward, these red and blue flashes burst into the upper atmosphere, sometimes stretching dozens of miles high. Pilots and astronauts have reported them for decades, but only in recent years have scientists begun capturing them on film. What's causing these unusual bursts of energy? Are they just a quirk of weather? Or could they be connected to larger forces we don't yet understand? Then there's the strange phenomenon of skyquakes, mysterious booms that shake buildings and rattle windows, often reported near coastlines but sometimes deep inland. They sound like explosions, yet no source is ever found. Some blame military tests, while others suggest meteors breaking apart in the upper atmosphere. But there are cases where none of these explanations fit. leaving open the possibility that Earth's atmosphere carries secrets we haven't unlocked. In fact, strange sounds from the sky, sometimes described as metallic trumpets or low droning hums, have been reported all over the world. Videos of these eerie noises often circulate online, sparking theories ranging from shifting tectonic plates to atmospheric resonance, or even signs of something otherworldly. Our atmosphere also serves as a battlefield for cosmic forces we rarely think about. Solar storms, bursts of energy from the sun, slam into Earth's magnetic field, creating dazzling auroras, but also disrupting satellites, communication systems, and even power grids. The Carrington event of 1859, the most powerful solar storm on record, fried telegraph wires and set equipment ablaze. If a similar storm struck today, it could cripple entire nations' power system. Scientists know these storms are inevitable, yet predicting their timing and strength remains an uncertain science. The atmosphere acts as our first line of defense, but it also makes us vulnerable when bombarded with cosmic energy we can't fully control. Another mystery lies in the jet streams, powerful rivers of air that flow high above the Earth. These streams shape global weather, but their shifts are becoming increasingly unpredictable. Climate change is altering their paths, causing strange and extreme weather events. Heat waves in the Arctic, freezing temperatures in places unaccustomed to them, and prolonged droughts where rain used to be reliable. Scientists can track these changes, but the deeper mechanics of how the atmosphere responds to global warming still puzzle researchers. Could there be tipping points within the atmosphere, hidden triggers that once set off unleashed chaos on a planetary scale? Beyond natural science, there are also whispers of the atmosphere being used in ways the public isn't told about. Conspiracy theories often swirl around projects like HAARP, the High-Frequency Active Auroral Research Program in Alaska. Officially, HAARP studies the ionosphere, the layer of the atmosphere that reflects radio waves. But critics have long claimed it could be used for weather modification, mind control, or even as a weapon. While mainstream science dismisses these ideas, the secrecy surrounding such projects fuels suspicion. After all, if the atmosphere can be manipulated by science or by nature, it represents one of the most powerful tools imaginable. Air travel also occasionally exposes atmospheric mysteries. Pilots have reported strange anomalies, sudden turbulence where none should exist, lights or objects appearing in thin air, and even disruptions in their instruments. While many of these incidents can be attributed to natural weather patterns or human error, the sheer number of unexplained reports hints that there are still forces at play in the skies that evade explanation. In some cases, entire aircraft have vanished, like Malaysia Airlines flight MH370, which disappeared in 2014 without leaving a clear trace. While the disappearance was over the ocean, the role of atmospheric conditions in what happened remains part of the speculation. And what about the idea of life above us? While Earth's surface teems with biodiversity, scientists have also discovered microorganisms drifting high in the atmosphere, surviving in conditions of freezing cold, low oxygen, and high radiation. Could the upper layers of Earth's skies harbour ecosystems we've barely begun to understand? Some even speculate that life could hitch a ride on atmospheric currents, travelling between continents or even arriving from space via meteors. The line between Earth's atmosphere and the wider cosmos isn't as firm as we might think. It's a zone of exchange, vulnerability and possibility. Perhaps the most haunting thought is this: the atmosphere is invisible, yet it dictates so much of our existence. We rely on it for every breath, every crop, every drop of rain. And yet it remains unstable, prone to sudden shifts and anomaly. It's not just a backdrop to our lives, it's an active player, capable of shaping history through droughts, storms and unseen forces. We may think we know the air around us, but in truth, we've only scratched the surface. So the next time you look up at the sky, remember, it isn't just empty blue, it's a living, shifting system filled with beauty, danger, and unanswered questions. From unexplained lights to invisible shields, from ancient legends of gods in the clouds to modern fears of climate collapse, the atmosphere holds secrets that shape our past, our present, and our uncertain future. And if the skies above us are filled with such mysteries, what happens when we look beneath the very ground we stand on? The Earth's crust, the layer that seems solid and dependable, may actually hold even stranger secrets than the air we breathe. We walk across it every day, build our homes upon it, and even dig into it for resources. Yet few people realize just how thin and fragile Earth's crust really is. Imagine the planet as a giant fruit. If Earth were an apple, the crust would be no thicker than the skin. Beneath that thin shell lies an enormous furnace of molten rock, pressure and mystery. It's ironic that while humanity dreams of colonizing space, we've barely scratched the surface of our own planet. The deepest hole ever drilled by humans, the Kola Super Deep Borehole in Russia, went only about 7.5 miles down, yet Earth's crust can be 25 to 40 miles thick under continents. In other words, we haven't even pierced through the skin of our world. And what scientists discovered during that drilling project wasn't just fascinating, it was unsettling. Temperatures were far higher than expected, strange sounds were recorded from deep underground, and the rocks revealed microscopic fossils of life that had been entombed for billions of years. The project eventually had to be abandoned, not because of lack of interest, but because the extreme heat and pressure made it impossible to dig any deeper. The crust is full of secrets. Mountains rise and fall as tectonic plates shift. Volcanoes explode with devastating force, reminding us that molten fire is always close beneath the surface. Earthquakes shake entire regions without warning, sometimes swallowing cities whole. What makes this even more chilling is that scientists admit we can't fully predict when or where the next catastrophic earthquake or volcanic eruption will strike. The crust is restless, alive in its own way, and it keeps humanity on edge. Ancient civilizations often viewed earthquakes and eruptions as the wrath of gods. But even with modern technology, we are no closer to fully taming these natural forces. Beneath the crust lies the mantle, a vast, semi-solid ocean of rock that moves slowly over millions of years. This movement drives plate tectonics, the process that reshapes continents, creates mountain ranges, and opens new oceans. But while the theory of plate tectonics explains a lot, there are still many mysteries. For example, scientists have discovered giant blobs deep within the mantle, some larger than continents that behave differently than the rock around them. No one knows exactly what they are. Remnants of ancient subducted plates, or something far stranger. Some researchers speculate that they could be linked to supervolcanoes or even mass extinction events. If true, then the Earth's crust is far less stable than we imagine, resting on top of colossal shifting anomalies that could reshape the planet in ways we can't control. The crust also holds strange anomalies that defy easy explanation. Take the Earth lights, or earthquake lights phenomenon. Strange glowing orbs or flashes that appear in the sky before or during seismic activity. Reports of these lights go back centuries, yet scientists still struggle to explain them. Are they caused by electrical charges released from rocks under stress? Or could they hint at unknown energies within the crust itself? Similarly, there are vast cave systems beneath the surface of Earth that remain unexplored. Some of these caves stretch for miles, containing underground rivers, bioluminescent life, and chambers so large they could fit entire cities. In some cultures, legends speak of inner worlds or subterranean civilizations hidden within the Earth. While mainstream science dismisses these ideas as myth, the fact remains that we have mapped the surface of Mars more thoroughly than we've mapped the vast labyrinths beneath our own feet. And then there are the mysteries linked to human history. Archaeologists have uncovered massive underground structures built by ancient civilizations, tunnels stretching for hundreds of miles across Europe, underground cities in Turkey capable of housing tens of thousands of people, and chambers filled with strange artifacts buried deep within the Earth. Why did our ancestors retreat beneath the crust? Were they hiding from cataclysmic events on the surface, or did they know something about the dangers above that we've forgotten? These questions add to the eerie allure of Earth's hidden worlds. Another enigma lies in magnetic anomalies. The crust contains vast deposits of iron and other minerals that affect Earth's magnetic field. In certain locations, like the Bermuda Triangle, pilots and sailors have reported strange disruptions in their compasses and instruments. While skeptics argue these are just natural variations, the sheer number of incidents fuels the idea that the crust may hold localized zones of magnetic energy capable of interfering with modern technology. If that's true, then these zones could represent more than just curiosities. They could be doorways to understanding forces that science hasn't yet grasped. Some of the most fascinating theories about Earth's crust come from ideas that blend geology with biology. Deep within the crust, microbes have been found thriving in extreme conditions, feeding on chemicals, surviving without sunlight, and adapting to pressures that would crush most life on the surface. This discovery has profound implications. It suggests that life isn't just a surface phenomenon. It may be embedded deep within the planet itself. Could it be that life on Earth actually began underground, protected from harsh conditions on the surface billions of years ago? If so, then our understanding of evolution and the origins of life may need to be rewritten. The crust also acts as a recorder of Earth's violent history. Layers of rock reveal past catastrophes, meteor impacts, massive volcanic eruptions, and sudden shifts in climate. For example, evidence of the asteroid that wiped out the dinosaurs 66 million years ago is preserved in a thin layer of iridium-rich clay found around the world. Similarly, massive lava flows buried beneath the crust tell the story of extinction events that nearly sterilized the planet. Each layer of rock is like a page in a hidden book, documenting a history more violent and unpredictable than we often realize. Yet for all that science has uncovered, the crust continues to hold countless unanswered questions. Could there be vast pockets of resources, water, or even unknown forms of energy hidden deep below? Some speculate that untapped reservoirs of geothermal power could fuel humanity's future, while others warn that drilling too deep might awaken forces better left alone. Science fiction often imagines catastrophic scenarios where humanity's curiosity leads to disaster. Yet real life has shown us that the crust can surprise us in ways we aren't prepared for. The 2010 eruption of Eyjafjallajökull in Iceland, for instance, paralyzed air travel across Europe for weeks, showing just how vulnerable modern society is to the whims of the Earth. Ultimately, the crust is a paradox. It is solid enough to walk on, build upon, and call home, yet fragile enough to split apart without warning. It is thin compared to the size of the Earth, yet thick enough to hide mysteries that we've barely begun to explore. It is both a protector, shielding us from the inferno below, and a threat, capable of unleashing destruction at any moment. When we think about the Earth's crust, it's easy to picture it as just rock and dirt. But the truth is, it's an active, unpredictable layer that holds the history of our planet, the possibility of hidden worlds, and the potential for catastrophic surprises. And as much as we'd like to believe we understand it, the reality is, we're only beginning to scratch the surface. If the thin skin of Earth holds such profound mysteries, what then lies deeper in the fiery heart of the planet? The mantle may move slowly, but the core, the beating heart of Earth, could hold secrets that change everything we think we know about the world beneath our feet. Beneath the thin and fragile crust of our world lies a realm that most people never think about. Yet it is responsible for shaping the planet we live on, the mantle. If the crust is the skin of Earth, the mantle is the muscle, and it is massive, making up nearly 84% of Earth's total volume, stretching from about 25 miles beneath the continents down to nearly 1,800 miles. It is a world of extreme pressure, searing heat, and slow, relentless movement. The mantle is not solid in the way most people imagine. Instead, it is a semi-solid flowing layer of rock that behaves almost like a very thick liquid over long periods of time. This slow movement is what drives the phenomenon we know as plate tectonics, the shifting, colliding, and tearing apart of continents and ocean floors. Every mountain range, every ocean trench, every earthquake and volcanic eruption can be traced back to the restless energy of the mantle. But what makes the mantle truly fascinating is that for all our scientific understanding, it remains one of the least explored parts of the planet. We cannot reach it directly. Even the deepest drilling projects haven't come close. Everything we know comes from indirect evidence: seismic waves generated by earthquakes, the chemistry of volcanic rocks, and computer models. Yet even with these methods, the mantle continues to defy easy explanation. One of the most puzzling discoveries in recent years is the existence of mantle plumes, massive columns of hot rock rising from deep within the Earth toward the surface. These plumes are believed to be responsible for volcanic hotspots like Hawaii and Yellowstone, but their exact origins remain a mystery. Are they fueled by heat from the core, or are they anomalies within the mantle itself, remnants of ancient processes that date back to Earth's earliest day? Some scientists even suggest that mantle plumes could be linked to supervolcanoes capable of altering the climate of the entire planet in a single eruption. The mantle is not uniform. It contains massive regions with unusual properties. Scientists using seismic imaging have discovered two gigantic structures deep within the mantle, each the size of a continent, one beneath Africa and the other beneath the Pacific Ocean. These anomalies, known as large, low shear velocity provinces, behave differently from the surrounding mantle, and may play a role in driving volcanic activity on the surface. Their sheer size and location suggest they could be connected to some of the most dramatic geological events in Earth's history, including the breakup of supercontinents and even mass extinction. The fact that such colossal features exist beneath our feet, yet we don't fully understand what they are, adds to the aura of mystery surrounding the mantle. Another striking aspect of the mantle is its role in recycling Earth itself. When tectonic plates collide, one plate is often forced beneath the other in a process called subduction. As it sinks into the mantle, the plate carries with it water, sediments, and sometimes even bits of the crust itself. Over millions of years, this material is remelted and eventually rises back to the surface as magma. In a sense, the mantle acts like Earth's stomach, digesting old crust and regurgitating it in the form of new land. This constant cycle of destruction and creation has been ongoing for billions of years, and without it, the Earth would be a very different planet. What's even more fascinating is that the mantle may hold vast reservoirs of water-hidden oceans trapped within its minerals. In 2014, scientists discovered evidence of a layer of water-rich minerals deep within the mantle, potentially holding 3 times the volume of all Earth's surface oceans combined. If true, this hidden water cycle could help explain why Earth has remained geologically active for so long, and why the surface has been able to sustain life. It also raises profound questions. Could these deep reservoirs influence earthquakes, volcanic activity, or even long-term climate cycles? And if there is so much water locked away underground, could other planets like Mars or Venus also hide similar secrets in their mantles, waiting to be discovered? The mantle is also linked to Earth's magnetic field, though indirectly. Movements within the mantle help transfer heat from the core outward, driving convection currents that keep Earth's interior dynamic. This heat flow plays a crucial role in powering the geodynamo in the outer core, which generates the magnetic field that shields our planet from harmful solar radiation. Without the mantle's restless motion, the core might cool too quickly, and Earth's protective magnetic field could collapse, leaving the planet exposed to deadly cosmic radiation. In other words, the mantle is not just a geological curiosity, it's a vital part of what makes Earth habitable. Yet for all these scientific insights, there are countless unanswered questions. For example, why does the mantle sometimes produce massive eruptions known as flood basalts events, so violent that they cover entire regions of the planet in lava? These eruptions have been linked to some of the greatest extinction events in history, including the one that paved the way for the rise of dinosaurs. Some researchers believe mantle plumes are to blame, while others think these eruptions are triggered by sudden shifts in heat flow between the core and mantle. The uncertainty leaves us uneasy, especially knowing that Earth has experienced such cataclysms before and may do so again. Adding to the mantle's enigma are the strange materials it occasionally pushes to the surface. Diamonds, for instance, are formed deep within the mantle under immense pressure, and volcanic eruptions sometimes carry them upward. But within these diamonds, scientists have discovered tiny inclusions of minerals that suggest conditions far stranger than we ever imagined. Minerals that can only exist under extreme pressures found hundreds of miles below the surface. These microscopic time capsules give us rare glimpses into a world otherwise inaccessible. They hint at processes and structures that we still can't fully explain, raising the possibility that the mantle hides entire realms of mineralogical diversity we've never encountered. Legends and myths have long hinted at a fiery world beneath the surface, and in many ways, the mantle fits that description. Ancient cultures often imagined the underworld as a place of heat and fire, and while their explanations were spiritual, they were eerily close to the truth. The mantle is a place of slow fire, not the raging inferno of myth, but a relentless, churning furnace that powers volcanoes and shapes continents. It is both a destroyer and a creator, capable of wiping out civilizations, yet also building the mountains and fertile soils that sustain life. Modern science paints the mantle as a dynamic system, but it doesn't erase the awe and mystery surrounding it. When we realize that every earthquake, every volcano, and every mountain range is the direct result of processes happening far beneath our feet, it's impossible not to feel humbled. The mantle is a reminder that Earth is not a static rock floating in space. It is alive in its own way, constantly moving, reshaping, and evolving. And as we look deeper, one question looms larger than all the rest. What role does the mantle play in the ultimate fate of our planet? Will its plumes trigger the next mass extinction? Will its hidden water keep Earth habitable for billions more years? Or will its movements eventually tear the planet's surface apart in ways we can't even imagine? The mantle may move slowly, but its influence is enormous, and its mysteries remain some of the most tantalizing in all of science. But beneath even the vastness of the mantle lies Earth's true core, the blazing heart of the planet, a realm of molten iron and unimaginable power. If the mantle is the muscle of the Earth, then the core is its beating heart, generating the magnetic field that protects us and holding secrets that could reshape everything we know about our world. And the deeper we go, the stranger the story becomes. At the very center of our planet lies something so extreme, so mysterious, that even with all the technology and science we possess today, we can only guess at what truly happens there. This is Earth's core, the hidden beating heart of the world. It is a place of fire and metal, where temperatures soar higher than the surface of the sun, and pressures are so crushing that matter itself behaves in ways that defy imagination. It is both the engine that powers much of the planet's surface activity and the shield that protects life from cosmic destruction. Without the core, Earth would not look the way it does, and we likely would not even exist. The core is divided into two parts, the outer core and the inner core. The outer core, located between 1,800 and 3,200 miles beneath our feet, is a swirling ocean of molten iron and nickel. Imagine a sea of liquid metal, constantly churning, roiling, and moving under the influence of heat, rising from the deeper layers. This movement is not random. It drives what scientists call the GI dynamo, the process that generates Earth's magnetic field. The inner core, on the other hand, is solid, despite its blistering heat. At around 9,000 to 10,000 degrees Fahrenheit, it should be molten, yet the overwhelming pressure keeps it locked in a rigid, crystalline state. The inner core is thought to be made mostly of iron, with some nickel and lighter elements mixed in, and it measures about 760 miles across, roughly the size of Pluto. But here's where the mystery deepens. We know the core is there because of how seismic waves from earthquakes travel through the planet, bending and bouncing in ways that reveal the inner structure. Yet even with this knowledge, scientists have uncovered bizarre anomalies. For instance, recent studies suggest the inner core might not be uniform. It may have different regions, some rotating slightly faster or slower than others. Some research even indicates that the inner core may be wobbling, shifting its orientation over time. If true, this could have profound implications for the magnetic field and, by extension, life on Earth itself. Speaking of the magnetic field, the role of the core in generating it cannot be overstated. Earth's magnetic field is like an invisible shield, deflecting solar winds and cosmic radiation that would otherwise strip away our atmosphere and fry the planet's surface. Mars, for example, once had a magnetic field, but when its core cooled and the field collapsed, the atmosphere was slowly eroded by solar radiation. Today, Mars is a barren, frozen desert, a chilling warning of what could happen if Earth's core ever stopped functioning. Every compass needle that points north is guided by forces unleashed thousands of miles below our feet. In a very real sense, the survival of life on Earth depends on the restless energy of the core. And yet, the core is unstable. The magnetic field it generates is not permanent. It has flipped many times in the past. Magnetic reversals, where the north and south poles switch places, have happened throughout Earth's history, sometimes lasting thousands of years. During these reversals, the magnetic field weakens, leaving the planet vulnerable. We are overdue for another reversal, and some scientists warn that signs of weakening have already begun. If Earth's magnetic field collapses, even temporarily, the effects would be catastrophic. Satellites could be fried, power grids could fail, and radiation levels on the surface could rise to dangerous levels. All of this stems from the turbulent dance of molten metal in the outer core. The core's mysteries don't stop there. Strange seismic readings have hinted at zones deep within the inner core, where the structure seems different from the rest, as if it contains hidden layers or even a separate innermost core. Some scientists believe this could be a relic from Earth's earliest days, when the planet first formed from molten rock and metal colliding in the chaos of the early solar system. If true, the inner core may be like a time capsule, holding clues to the birth of Earth itself. Unlocking those secrets could transform our understanding of how planets form and evolve, not just here but throughout the universe. And then there are the truly unsettling theories. Some researchers speculate that the inner core might not be made of iron alone. Exotic materials, perhaps even forms of matter that don't exist anywhere else on Earth's surface, could be hiding there. Others suggest that fluctuations in the core could be linked to unexplained phenomena, from sudden climate shifts to strange, low-frequency sounds recorded deep within the planet. There are even fringe theories that claim civilizations or advanced technologies could somehow exist in hidden realms below the surface, though mainstream science dismisses these as fantasy. Still, the fact remains, we cannot drill to the core, and so much of what we say about it is based on inference, models, and indirect evidence. The unknown looms large. The power of the core is not just theoretical, it manifests on the surface in ways we can see and feel. Volcanic eruptions, earthquakes, and the slow drift of continents are all connected in one way or another to the heat and energy escaping from the planet's center. That heat is what keeps the mantle flowing, driving tectonic plates and shaping Earth's geography. Without the core's fiery heart, Earth would be a geologically dead planet, much like the Moon, silent, motionless, and lifeless. The core is the pulse that keeps our world alive. But what about the future? Scientists estimate that Earth's core has been slowly cooling since the planet formed 4.5 billion years ago. One day, billions of years from now, the core may solidify completely, shutting down the geodynamo and extinguishing the magnetic field. If humanity or any form of life still exists then, they would face a grim fate. The atmosphere would be stripped away, radiation would bombard the surface, and Earth would become another Mars. The thought is sobering, but it also reminds us of how precious the present is, how lucky we are to live on a planet whose core is still vibrant, still alive. Even today, the core may play a role in cycles we don't fully understand. Some studies have linked fluctuations in Earth's magnetic field to changes in climate patterns, suggesting a deeper connection between the fiery heart of the planet and the conditions on the surface. If this link proves real, it would mean that our weather, our oceans, and even the survival of ecosystems may be influenced by forces miles beneath our feet. It is humbling to realize that the foundation of life itself may be tied to molten metal swirling in the dark. Legends across cultures have long spoken of a fiery underworld beneath the earth, a realm of gods, demons, or hidden powers. In their own way, these myths may have been humanity's attempt to explain the strange, powerful forces that seem to rise from below: earthquakes, volcanic eruptions, and unexplained magnetic phenomena. Today, we no longer frame these mysteries in terms of myth, but the awe remains. The core is still, in many ways, a forbidden world, inaccessible and unknowable, yet vital to everything we hold dear. So the next time you feel the ground shake beneath your feet or see a compass needle twitch, remember this: you're witnessing the heartbeat of a planet. A fiery heart that has been beating for billions of years. A heart that shields us, shapes us, and defines us, but like all hearts, it will not beat forever. And what happens when it finally stops is a question that haunts both scientists and dreamers alike. The deeper we go into Earth's mysteries, the stranger and more captivating the story becomes. The core, as powerful as it is not the final word. Beyond the molten depths lies another force just as vital and just as mysterious: the oceans that cover most of Earth's surface. They may seem familiar, but in truth, they are just as unexplored and full of secrets as the core itself. And what they hide could be even more shocking than the fires beneath our feet. If the Earth's core is the blazing heart of the planet, then the oceans are its lungs, vast, restless, and essential to every breath of life above. Covering more than 70% of the planet's surface, the oceans are so immense that they shape our climate, control our weather, feed billions of people, and act as the cradle of life itself. And yet, for all our technological advancement, these waters remain an enigma. We've sent humans to the moon, deployed rovers on Mars, and are planning missions to distant worlds, but more than 80% of Earth's oceans are still unmapped and unexplored. Let that sink in. The largest habitat on our planet is essentially unknown to us. At first glance, the oceans may seem calm, almost ordinary. We swim in them, fish in them, and sail across them every day. But beneath that glittering surface lies a world so alien and extreme, it might as well belong to another planet. As you descend into the deep, sunlight fades and vanishes entirely after just a few hundred meters. Pressure builds relentlessly, crushing with forces that would snap steel and pulverize bones. Temperatures drop to freezing in some regions, while in others volcanic vents spew superheated water laced with chemicals toxic to most forms of life. This twilight and midnight zone, as scientists call it, is home to creatures that defy our imagination, beings with bioluminescent organs that glow like living lanterns, animals with translucent skin, oversized teeth, and bodies adapted to endure conditions we can barely replicate in laboratories. And the further down we go, the stranger it becomes. At depths of over 36,000 feet lies the Mariana Trench, the deepest known point in Earth's oceans. Only a handful of human missions have ever ventured into its black abyss. What they found was both fascinating and unnerving. Life flourishing in conditions once thought impossible. Microbes thriving on rocks and chemicals rather than sunlight. And fish with bizarre, almost otherworldly features. Every descent into these depths reveals something new, but also something unsettling. If life can survive here in darkness and crushing pressure, what other forms of life might exist elsewhere in the universe, in the oceans of Europa or Encelada? Yet even the known mysteries are enough to keep scientists awake at night. One of the most puzzling phenomena comes from the sounds recorded in the deep ocean. Hydrophones have picked up eerie noises like the infamous bloop detected in the 1990s that are so loud and so unusual they defy explanation. Some were later traced to ice quakes, massive chunks of ice breaking off Antarctica, but others remain unresolved. These sounds remind us that the ocean hides not only creatures but also geological processes we don't fully understand. Some even speculate that these unexplained noises might point to giant undiscovered species lurking in the dark. It may sound like science fiction, but remember, the giant squid, once dismissed as myth, turned out to be real, and it was only confirmed in recent decades. The oceans are also keepers of human history. Entire civilizations have been lost to their depths, swallowed by rising seas or catastrophic events. Ancient cities like Heracleion and Pavlopetri lay hidden beneath the waves for thousands of years before divers rediscovered them. Myths of Atlantis, though likely just legend, reflect a universal human awareness of how the sea can both give and take. And today, some researchers argue that there could be many more sunken ruins waiting to be found, buried under silt, hidden in trenches, or masked by shifting sands. With sea levels rising faster now than at almost any time in recorded history, who knows what forgotten stories may be uncovered in the decades to come. But the oceans aren't just mysterious, they're dangerous. Rogue waves, massive tsunamis and undersea earthquakes can strike without warning, reshaping coastlines and destroying lives in moments. These events are driven by the restless movements of tectonic plates, powered in part by the mantle and core, magnified by the sheer size of the oceans themselves. In 2004, a massive undersea earthquake triggered a tsunami in the Indian Ocean that claimed more than 200. Events like these remind us that the oceans are not just passive backdrops to our planet. They are forces of nature, capable of immense destruction. And there's another danger lurking in the deep, one that's quieter, slower, but perhaps even more threatening. The oceans are changing. Climate change is warming their waters, melting ice caps, and altering currents that regulate weather around the globe. Coral reefs, home to some of the richest ecosystems on Earth, are dying at alarming rates. Rising acidity threatens the very survival of marine species, while overfishing pushes countless animals to the brink of extinction. These changes don't just affect the ocean, they ripple across the entire planet, reshaping climates, economies, and societies. Yet, amid all this, the oceans still hold secrets that spark wonder. Hydrothermal vents discovered in the late 1970s revealed ecosystems powered not by sunlight, but by chemicals spewing from Earth's crust. Entire communities of giant tube worms, clams, and shrimp live in symbiosis with bacteria that convert toxic gases into energy. These discoveries shattered the idea that sunlight was essential for life, expanding our understanding of what life is and where it can exist. Suddenly, the possibility of alien life in the oceans of icy moons seemed not just plausible, but likely. The oceans of Earth became a model for the cosmos. And then there are the questions that border on the legendary. Sailors for centuries spoke of sea monsters, colossal creatures lurking beneath the waves. Were these just tall tales or echoes of encounters with real, enormous animals like giant squids or undiscovered leviathans? Every year, scientists stumble upon new species in the ocean, from tiny plankton to massive fish, reminding us that we still don't know what's out there. Could the legends of sea serpents or krakens have some basis in reality? Until we've mapped and studied the entire ocean, and that day is far away, we can't say for sure. Even in modern times, mysteries persist. Strange lights have been reported deep underwater, phenomena unexplained by known forms of bioluminescence. Massive, unexplored trenches may conceal ecosystems untouched by humans, where evolution took a completely different path. Some researchers have even speculated that ancient extraterrestrial objects, asteroids or spacecraft, could lie hidden in the ocean floor, preserved by the sediment and darkness. These ideas may sound wild, but the ocean is vast enough to make even the improbable possible. What's most unsettling about the ocean is that we are so dependent on it, yet we understand it so poorly. It produces over half of the oxygen we breathe, absorbs much of the carbon dioxide we emit, and stabilizes the planet's climate. Without it, Earth would be unrecognizable and likely uninhabitable. And yet, despite its importance, we treat it recklessly, polluting it with plastics, chemicals, and oil spills. We are, in many ways, poisoning our own lifeline, and the consequences may already be catching up with us. The ocean is Earth's greatest paradox, a place of life and death, beauty and terror, knowledge and ignorance. It sustains us, yet it also hides dangers we cannot fully predict. It is a reminder that our planet is still wild, still mysterious, still capable of surprising us in ways we cannot imagine. And every time a new expedition sets out into the depths, we hold our breath, because what they bring back might change how we see the world forever. But the story of Earth doesn't stop with oceans. Just as the seas conceal hidden truths, so does the very atmosphere above us. The invisible veil that shields us shapes our climate, and may hold secrets as unsettling as the deepest trench. And what lies beyond that veil is the next chapter in understanding Earth's place in the cosmos. When we look up at the sky, it feels infinite, a vast canvas of blue by day and scattered stars by night. But in truth, Earth's atmosphere is a fragile skin, a thin veil compared to the size of the planet itself. If Earth were shrunk down to the size of an apple, the atmosphere would be no thicker than its skin. And yet, this delicate layer is all that stands between us and the raw, deadly emptiness of space. Without it, life as we know it would vanish in an instant. But just because it's invisible doesn't mean it's simple. On the contrary, the atmosphere is a realm of power, mystery, and sometimes danger, shaping every breath we take, every storm we face, and even the survival of our species. The atmosphere is divided into layers, each with its own character. Closest to us lies the troposphere, where we live, where clouds form, and where storms rage. It's the most familiar but also the most chaotic, constantly in motion, swirling with winds and pressure systems that give birth to hurricanes, tornadoes, and monsoons. Above that is the stratosphere, home to the ozone layer, our shield against the sun's deadly ultraviolet rays. Higher still, in the mesosphere and thermosphere, the air grows thin, temperatures swing wildly, and phenomena like meteors burning up or the auroras dancing across the sky take place. Beyond them lies the exosphere, where the atmosphere fades into the void of space. This layered structure may seem straightforward, but what happens within it is anything but. One of the most mysterious forces within our atmosphere is lightning. We think of it as a familiar storm phenomenon, a sudden flash followed by thunder, but the truth is far stranger. Scientists still don't fully understand how lightning forms or why it behaves the way it does. Some bolts stretch for hundreds of miles, while others travel upward into space in the form of sprites and blue jets, dazzling flashes of plasma that connect storms with the edge of space. These upper atmosphere lightning events, only recently documented with modern cameras, suggest that the boundary between Earth and the cosmos is far more active and connected than we once thought. Lightning is a reminder that even in phenomena we think we understand, mysteries still abound. Then there's the atmosphere's role as a cosmic shield. Every day, Earth is bombarded by meteoroids, chunks of rock, metal, and debris drifting through space. Most of them burn up harmlessly in the atmosphere, creating the streaks of light we call shooting stars. Without this protective barrier, our planet would be pockmarked like the moon, scarred by countless impacts. But the atmosphere doesn't just shield us from physical objects, it also deflects harmful radiation from the sun and beyond. High-energy cosmic rays constantly stream toward Earth, and while some penetrate, much of it is absorbed or redirected by the atmosphere in tandem with the planet's magnetic field. Without this defense, life could never have flourished on Earth's surface. But the atmosphere is not only a protector, it can also turn against us. The same forces that sustain life also create chaos. Hurricanes are born when warm ocean waters feed energy into the atmosphere, creating storms so powerful they can wipe out entire cities. Tornadoes form from violent clashes of air masses, spinning with such intensity they rip buildings apart in seconds. Heat waves, droughts, and floods, all are the atmosphere's way of redistributing energy across the planet. But to us, they're disasters. And as climate change accelerates, these events are becoming more extreme, more unpredictable, and more devastating. The invisible blanket that keeps us alive is also the agent of some of our greatest fear. Then there are the strange sounds of the sky, mysterious booms, hums, and crackles that have been reported across the world. Sometimes these are traced to atmospheric phenomena, like meteors exploding high above the Earth, or shifts in temperature layers that bend and amplify sound waves. Other times, the source remains unknown. In recent decades, people in cities around the globe have reported sky trumpets, eerie sounds that rumble and echo as if the heavens themselves were groaning. Scientists speculate about atmospheric pressure shifts, industrial noise, or seismic activity, but no single explanation accounts for them all. For many, these sounds remain unsettling reminders that the sky is alive in ways we don't fully understand. The atmosphere is also the stage for optical illusions that feel almost supernatural. Sundogs, halos, and light pillars, caused by ice crystals refracting sunlight, can create glowing circles and beams in the sky, phenomena so strange that ancient civilizations often interpreted them as omens. Mirages bend light to make distant objects appear close, or water shimmer on a hot road. And then there are the auroras, the northern and southern lights. These spectacular displays are created when charged particles from the sun collide with Earth's upper atmosphere, igniting waves of green, purple, and red light that dance across the poles. They're not just beautiful, they're evidence of Earth's constant battle with the forces of space. A single solar storm strong enough could overwhelm our atmosphere's defenses, disabling satellites, knocking out power grids, and plunging modern civilization into chaos. Air itself holds secrets. Every breath we take is a mixture of nitrogen, oxygen, carbon dioxide, and trace gases. But within that mixture lies the story of life and death. Oxygen wasn't always present in Earth's air. Billions of years ago, the atmosphere was toxic, dominated by methane and carbon dioxide. It was only when cyanobacteria, primitive microbes, began producing oxygen through photosynthesis that the air became breathable, triggering what scientists call the Great Oxidation Event. This moment transformed the planet, paving the way for complex life forms like us. But the balance remains fragile. A rise or fall in certain gases can alter the climate dramatically, sparking ice ages or greenhouse worlds. We think of air as ordinary, but it is the product of ancient events that still govern the fate of humanity. There are also questions about what might be lingering in the atmosphere that we can't see. High above the Earth in the stratosphere, microbes have been discovered clinging to dust particles, surviving in conditions of extreme cold and radiation. Could the sky itself be a reservoir of life drifting invisibly above our heads? And if microbes can survive in our upper atmosphere, could similar organisms exist in the skies of other planets, like Venus, which has thick clouds filled with strange chemistry? These questions blur the line between Earth's mysteries and the search for extraterrestrial life. But perhaps the greatest enigma of the atmosphere lies in its future. Human activity is altering it at an unprecedented pace. We've filled the air with greenhouse gases, triggering climate change. We've thinned the ozone layer with chemicals, though international efforts have begun to repair it. We've polluted the skies with smog, choking cities and shortening lives. And now we face the uncertain consequences of these actions. Will rising temperatures destabilize weather systems to the point of catastrophe? Could melting permafrost release vast amounts of methane, accelerating warming even further? The atmosphere's fragility makes these scenarios more than science fiction. They are possibilities that scientists warn could unfold within our lifetimes. Still, for all its dangers and mysteries, the atmosphere is also a place of wonder. It is the reason we can see sunsets painted in hues of red and orange, hear the crack of thunder echo across valleys, and feel the cool breeze that carries the scent of rain. It connects us to the past, reminding us of the cyanobacteria that shaped it billions of years ago, and to the future, as we grapple with the consequences of how we treat it today. It is both ordinary and extraordinary, something we take for granted and yet cannot live without. The atmosphere teaches us a sobering truth. The most powerful forces shaping our world are often the ones we cannot see. Invisible gases, unseen currents, and forces beyond our comprehension determine the fate of every living thing on this planet. And if we have learned anything from studying the Earth, it's that what we think we know is often only the beginning. But the story of Earth's invisible powers doesn't end with the sky. Beyond the atmosphere lies space itself, where Earth's magnetic field reaches out like an invisible shield, and where the sun's energy plays a game of balance and destruction. To truly understand Earth's mysteries, we must step past the veil of air and into the void, where the boundaries between planet and cosmos blur, and where the next great secrets of our world may lie waiting. When people think about what protects us from the deadly emptiness of space, they imagine the atmosphere, and while that's true, there is another guardian that shields us silently, invisibly, and constantly. Earth's magnetic field. It doesn't shimmer in the sky or make a sound, but without it, life on this planet would be exposed to radiation so extreme it would strip away our air, boil our oceans, and leave Earth barren like Mars. The magnetic field is like an unseen fortress, a bubble scientists call the magnetosphere, and its mysteries stretch far beyond what most people realize. It is not simply a static shield. It pulses, shifts, and sometimes even falters, leaving us vulnerable to the storms of space. To understand it is to see Earth not as an isolated planet, but as a player in a cosmic battlefield, forever at the mercy of forces beyond our control. The magnetic field begins deep within Earth itself in the molten outer core. This layer, made of liquid iron and nickel, churns and flows like a vast ocean of metal. As it moves, it generates electrical currents, and those currents create a magnetic field that extends outward into space. This dynamo effect is one of the most extraordinary natural processes we know of, but it's also fragile. For reasons still not fully understood, the magnetic field flips from time to time, reversing north and south. These reversals happen irregularly, sometimes every few 100,000 years, sometimes millions of years apart. The last full reversal happened roughly 780,000 years ago, and there are signs we may be heading toward another one. What happens during such an event is one of the great scientific mysteries of our time. Would satellites fail? Would compasses go haywire? Would Earth's surface be bombarded by radiation? We don't yet know, and that uncertainty is as unsettling as it is fascinating. The magnetosphere's greatest enemy is the sun. Our star is not a gentle, steady lamp in the sky. It's a raging, boiling sphere of plasma, constantly hurling out charged particles in what's known as the solar wind. Most of the time, Earth's magnetic field deflects these particles, redirecting them harmlessly around the planet. But every so often, the sun erupts in violent solar storms, flares and coronal mass ejections that blast billions of tons of charged material into space. If one of these storms collides with Earth, it can compress the magnetosphere, disrupt satellites, and trigger massive geomagnetic storms. The most famous example is the Carrington event of 1859, when telegraph systems around the world sparked, caught fire, and even shocked operators. If such a storm struck today, it could cripple power grids, shut down GPS systems, and plunge much of modern civilization into chaos within hours. Scientists warn it's not a question of if, but when. But there's a beautiful side to this battle too. When charged particles from the sun interact with Earth's magnetic field, they are funneled toward the poles, where they collide with atoms in the upper atmosphere. These collisions release energy in the form of light, creating the auroras, the northern and southern lights. To ancient civilizations, these glowing curtains of green, red, and purple were messages from the gods, omens of war, or souls crossing into the afterlife. Today, we know they are the visible scars of cosmic warfare between the sun and Earth, dazzling reminders that we live in the path of forces far greater than ourselves. Yet the magnetic field isn't perfect. There are weak spots, anomalies that defy expectations. One of the most puzzling is the South Atlantic anomaly, a region stretching from South America to Africa where Earth's magnetic field is unusually weak. Satellites passing through this zone often experience malfunctions, glitches, or radiation damage. Some scientists believe it may be a sign that the magnetic field is in the early stages of reversing, while others argue it's just part of its natural fluctuation. Either way, it's a stark reminder that the shield we rely on is not unbreakable, and that space itself is constantly pressing against us looking for cracks. Earth's place in the cosmos is not one of safety, but but of survival. Our planet orbits in what astronomers call the habitable zone, the narrow band around a star where liquid water can exist. It's often nicknamed the Goldilocks zone because everything is just right for life. But being in this zone doesn't guarantee safety. Too close to the sun, and Earth would resemble Venus, a world of crushing heat and toxic clouds. Too far, and we'd become like frozen Mars. Even within this zone, we depend on a delicate balance of atmosphere, magnetism, and geology to maintain life. Every factor works together, and a disruption in one could unravel the whole system. It's not exaggeration to say that Earth's survival has been as much luck as design. Then comes the question of neighbors. Mars, once thought to be a dead planet, shows evidence of rivers, lakes, and perhaps even oceans in the distant past. But without a strong magnetic field, Mars lost its atmosphere, stripped away by the relentless solar wind. What remains is a barren desert world, scarred by canyons and dust storms. Scientists look at Mars as a warning, an example of what could happen if Earth ever loses its protective shield. On the other end, Venus has a thick atmosphere, but it's a suffocating greenhouse blanket, trapping so much heat that its surface can melt lead. In the cosmic lottery, Earth seems to have hit the jackpot, but the stories of its neighbors show how fragile that victory really is. Space, however, isn't just a threat, it's also a mirror. By studying the cosmos, we learn more about ourselves. Astronomers have discovered thousands of exoplanets, some orbiting within their stars' habitable zones, and yet, even among these Earth-like planets, few seem to have the exact conditions we enjoy. Many lack protective magnetic fields. Others orbit volatile stars that flare too violently for life to endure. It raises a profound question. Is Earth truly unique, or are we just one of many rare survivors in a hostile universe? The answer remains hidden, but the search continues. And beyond physical survival, there's the question of meaning. To ancient humans, the night sky was not just a backdrop, it was a map of gods, myths, and destiny. The stars guided navigation, inspired religions, and sparked countless stories of creation and apocalypse. Even today, the cosmos holds a psychological pull on us. We build telescopes, launch probes, and dream of colonizing other worlds. But deep down, the fascination is rooted in something primal, the recognition that our home is not the center of the universe, but a fragile world adrift in an ocean of stars. The truth is, Earth's place in the cosmos is precarious. At any moment, an asteroid could change everything. A solar storm could dismantle our technology, or a shift in the magnetic field could leave us exposed. And yet, life goes on. We build cities, dream of the future, and gaze at the stars as if they're ours to conquer. Perhaps that's humanity's greatest strength, the ability to live with danger hanging over us and still find wonder in the sky. The story of Earth's magnetism and cosmic place is not one of certainty but of balance, fragile, temporary, and endlessly fascinating. It teaches us that survival is not guaranteed, that luck and chance play as much of a role as science and adaptation, and it leaves us with the humbling realization that in the vastness of space, our planet is both insignificant and extraordinary, a tiny dot that has managed to harbor life against impossible odds. But while we marvel at the cosmos, there is another mystery closer to home, hidden deep within the Earth itself. Beneath our feet lies a world we cannot see, a realm of molten rock, crushing pressure, and secrets that may hold the key to the planet's fate. The journey inward into Earth's core reveals dangers and wonders that rival anything in space. And as we shift our gaze downward, the story of Earth becomes even stranger. When most people look around, they see the surface of Earth, mountains, oceans, forests, and cities. But the truth is, everything we know and everything we stand on is just the thinnest skin of a vast and layered planet. Beneath our feet lies an alien world that no human has ever seen directly. We can only study it through seismic waves, magnetic readings, and clever deductions. Yet what scientists have uncovered about Earth's core is as fascinating as any science fiction story. It's a realm of crushing pressures, molten metals, and colossal forces that shape not only the ground we walk on, but the very life we live. The core is Earth's beating heart, and its mysteries remain some of the most thrilling unsolved puzzles in science. The journey inward begins just beneath the crust, where we descend into the mantle, a layer that stretches down thousands of kilometers. This mantle is not a solid rock slab as people imagine, but a zone of slow-flowing material, rock that is solid yet behaves like a thick, viscous liquid over immense timescales. It is here that convection currents churn like a boiling pot, driving the movement of tectonic plates above, but deeper still, the mantle gives way to the outer core, a layer of liquid iron and nickel. Imagine oceans of molten metal, swirling under pressures millions of times greater than the atmosphere. This liquid core, about 2,200 kilometers thick, is in constant motion, and it is this motion that creates the magnetic field protecting our planet. The swirling outer core is Earth's dynamo, powering the invisible shield that stands between life and cosmic destruction. Without it, Earth would be unrecognizable. But then we arrive at the inner core, perhaps the most mysterious part of all. Unlike the outer core, the inner core is solid. It shouldn't be, according to common sense. Temperatures there soar to over 5,000 degrees Celsius hotter than the surface of the sun, and yet, the crushing pressure at that depth forces the iron and nickel into a solid sphere roughly the size of the moon. It is this inner core that keeps the entire planet balanced. Its existence not only drives the geodynamo effect, but also reveals secrets about Earth's origins. The inner core is thought to be growing, crystallizing slowly over billions of years as the planet cools. This growth releases energy that fuels the churning of the outer core. In other words, the heart of Earth is still alive, still changing, still shaping the world above. And here's where the mystery deepens. Scientists recently discovered that the inner core may not be a uniform solid at all. Seismic studies suggest it could have layers within layers, like a planet inside a planet. Some evidence points to the existence of an innermost inner core, a region that behaves differently from the rest, aligned along a different axis. It's as if Earth's heart has a hidden heart of its own. Why does it exist? What does it mean for the stability of our magnetic field and the future of the planet? These are questions no one has yet answered, but the story doesn't stop at structure. It also ties into Earth's history. Billions of years ago, when Earth was young, its core may not have been as stable. Some scientists believe the magnetic field flickered in and out of existence during the early stages, leaving the surface exposed to brutal radiation. If that's true, life may have had to struggle harder to gain a foothold, surviving in sheltered places like the deep ocean or underground. It's even possible that the stabilization of Earth's inner core, which occurred about 1.5 billion years ago, marked a turning point in the planet's history. With a reliable magnetic field, Earth could finally shield itself consistently, creating an environment where complex life could thrive. In a way, the core didn't just shape the land, it shaped evolution itself. What's most mind-bending, though, is how little we actually know. No machine, no drill, no human expedition has ever gotten anywhere near the core. The deepest hole humanity has ever dug, the Kola super-deep borehole in Russia, reached just over 12 kilometers. That's less than a pinprick on Earth's skin, compared to the 6,371 kilometers down to the center. Everything beyond comes from indirect evidence. Seismic waves from earthquakes act like X-rays, bending and reflecting differently depending on the material they pass through. By studying these waves, scientists piece together a picture of the unseen, but this picture is still blurry, and every new discovery adds more questions than answers. The core also raises another tantalizing possibility. Could it be influencing the surface in ways we don't yet understand? Scientists know that mantle plumes, columns of hot material rising from the core mantle boundary, create volcanic hotspots like Hawaii and Iceland. But could there be deeper connections between the inner core's growth and surface events such as plate tectonics or even climate change? Some research hints at long-term links, suggesting that changes in the deep Earth could ripple upward over millions of years, shaping continents and oceans in ways we can't yet grasp. There is also a darker side to this story. If the inner core stopped growing, or if the outer core's movement slowed, the magnetic field would weaken. Without that shield, Earth's atmosphere could be stripped away, just like Mars. Radiation from the sun would bombard the surface, making it increasingly hostile for life. Technology would collapse under geomagnetic storms, and the biosphere would unravel. It's a doomsday scenario that feels distant, but it reminds us how utterly dependent we are on forces hidden deep within the planet. The heart of Earth is not just a curiosity, it's our lifeline. The core also connects us to other worlds. Scientists studying exoplanets have realized that many rocky planets might lack magnetic fields, making them vulnerable to their stars. Even within our own solar system, Mars and Venus tell cautionary tales. Mars lost its dynamo early on, leaving it exposed and barren. Venus, despite its size, seems to lack a strong magnetic field, leaving its thick atmosphere dominated by crushing greenhouse effects. Earth's vibrant core sets us apart, making life not only possible but sustainable across billions of years. It's a cosmic gift that might be far rarer than we think. Yet, despite all of this, the core is still one of the most inaccessible places in science. Every time we think we understand it, new data disrupts the picture. Some scientists speculate that strange particles, perhaps neutrinos, could reveal more about the processes happening there. Others dream of building advanced seismic networks to map it in higher resolution. There are even daring ideas about one day sending autonomous probes into the mantle, though reaching the core itself remains far beyond human technology. Still, the pursuit continues, driven by the realization that Earth's greatest secrets lie not in the stars, but beneath our feet. The heart of Earth is both familiar and alien. It is made of the same metals we use to build cities and machines, yet it exists in a state we can hardly imagine. An immense crucible of fire and pressure, eternal and dynamic, it shapes the sky above, the land we walk on, and even the survival of life itself. And the deeper we study it, the more it reminds us that the planet is alive in ways we're only beginning to understand. But if the inner Earth tells us about survival, the outer Earth, the part exposed to cosmic impacts and human influence, tells us about fragility. Because while the core keeps us alive, there are forces from above and beyond that constantly threaten to undo everything. And what comes next in this story reveals just how close Earth has come to losing everything more than once. If the Earth's core represents the unseen engine of survival, then space represents the constant threat of destruction. Throughout Earth's 4.5 billion year history, our planet has been bombarded by countless rocks from the heavens, asteroids, comets, and other cosmic debris. Some impacts were small, carving craters that we barely notice, but others were catastrophic, changing the entire direction of life on Earth in the blink of an eye. To understand just how fragile our existence is, we need to look at these collisions not as rare accidents, but as repeating events in Earth's story. The scars of these encounters are written in the rocks buried under oceans, and sometimes hidden in plain sight. Every strike carries a chilling reminder: life is at the mercy of the universe, and no amount of human technology has fully removed that danger. The most famous of these disasters is, of course, the asteroid impact that ended the reign of the dinosaurs about 66 million years ago. Imagine it, a rock roughly 10 kilometers across, slamming into the Yucatan Peninsula with the force of over 1 billion nuclear bombs. The explosion unleashed tsunamis, earthquakes, and shockwaves that flattened everything for thousands of miles. But the most devastating consequence wasn't the immediate destruction. It was what came after. Dust and sulfur were thrown so high into the atmosphere that they wrapped the planet in a choking blanket, blocking out sunlight for months, maybe years. Without sunlight, plants withered, food chains collapsed, and 3/4 of all species vanished. The dinosaurs, which had ruled for over 160 million years, suddenly became extinct, leaving the way open for mammals and eventually humans to rise. This single event reshaped the history of Earth and everything that would follow. But the dinosaur-killing asteroid was not unique. Long before that, Earth had already been struck by cosmic bodies with devastating results. Around 2 billion years ago, the Vredevert impact in what is now South Africa carved out a crater over 300 kilometers wide. It remains the largest confirmed impact structure on Earth, though much of it has eroded away. Even earlier, the Sudbury Basin in Canada was formed by another massive collision over 1.8 billion years ago. These ancient impacts may not be tied to specific extinction events because life was still microbial at the time, but their effects on the planet's crust, atmosphere, and even mineral deposits were profound. Some scientists believe impacts like these may have even supplied the building blocks of life itself, delivering water and organic molecules from space. Moving forward in time, we see that impacts became less frequent but no less dangerous. About 35 million years ago, Earth was hit by not one but 2 large objects within a short span of time. The Chesapeake Bay impact in present-day Virginia created a crater 85 kilometers wide, while the Popogai impact in Siberia carved out a crater over 90 kilometers across. Both strikes unleashed destruction on a continental scale. Some researchers argue that they may have caused climate shifts that rippled across the globe. Life survived, but the message was clear. These collisions were not random freak occurrences. They were and still are, part of Earth's ongoing relationship with the solar system. Even smaller impacts can have outsized consequences. In 1908, a relatively small asteroid or comet exploded over Tunguska, Siberia, flattening over 2,000 square kilometers of forest. The blast was equivalent to about 15 megatons of TNT, roughly 1,000 times the atomic bomb dropped on Hiroshima. Luckily, it occurred in a remote area, sparing human lives. But imagine if Tunguska had happened over London, New York, or Beijing. The devastation would have been unimaginable, and that was just a tiny fragment compared to the giants that shaped Earth's history. What's truly unsettling is how often these events nearly slip past us. In 2013, a meteor exploded over Chelyabinsk, Russia. The shockwave injured over 1,500 people, shattering windows and collapsing roofs. That object was only about 20 meters wide, small enough to go undetected until it entered the atmosphere. If it had exploded closer to the ground, the death toll could have been catastrophic. And here's the kicker: while larger asteroids are tracked, smaller ones, the kind that could wipe out a city, often slip through unnoticed. Now imagine an object much bigger heading our way. Astronomers estimate that there are thousands of near-Earth objects large enough to cause regional or even global destruction. And while none pose an immediate confirmed threat, immediate in astronomical terms can mean centuries or millennia. Statistically, it's not a question of if Earth will be hit again, it's a question of when. Humanity may have built rockets, satellites, and telescopes, but our ability to stop a fast-moving asteroid is still experimental at best. Projects like NASA's DART mission, which successfully nudged an asteroid's trajectory, prove that deflection is possible, but scaling that up to stop a rock kilometers wide is an entirely different challenge. Beyond the threat of extinction, impacts have shaped Earth in ways we rarely acknowledge. Many of the planet's valuable mineral deposits, including nickel, platinum, and even diamonds, may owe their existence to the immense pressures and heat unleashed during ancient collisions. Entire geological regions bear the fingerprints of impacts that melted rock and altered landscapes forever. Even the Moon itself, which stabilizes Earth's tilt and tides, is believed to have formed from a colossal collision between the young Earth and a Mars-sized body. Without that event, Earth's history and perhaps life itself would be radically different. But while these impacts brought destruction, they also forced evolution forward. Mass extinctions create opportunities. When dominant species vanish, new ones take their place, often more adaptable and innovative. Without the asteroid that wiped out the dinosaurs, mammals may never have flourished, and humans may never have appeared. In this way, cosmic catastrophes are both destroyers and creators. They remind us that progress often emerges from chaos, even if the cost is unthinkably high. And here's the uncomfortable truth: we are overdue. The last extinction-level impact happened 66 million years ago, and while such events are rare, they are not one-time anomalies. Geological records suggest that Earth has faced at least 5 major extinction events, many linked to cosmic impacts or volcanic activity triggered by them. The cycle of destruction and rebirth is written into the DNA of the planet. If history is any guide, another strike is inevitable. This looming threat also raises philosophical questions. Humanity has the unique ability to foresee potential dangers, and perhaps to prevent them. But will we act in time, or will we, like the dinosaurs, be caught unprepared? Every fireball streaking across the night sky is a reminder that the universe does not care about human survival. Our only chance lies in vigilance, preparation, and the will to cooperate as a species to defend the only home we have. In the end, asteroids and comets are more than random rocks wandering through space. They are storytellers of Earth's past and harbingers of its possible future. They have the power to end civilizations in seconds and the power to shape evolution across eons. Their impacts are both tragedies and turning points, reminders of how fragile life is and how easily everything can change. The ground we walk on, the air we breathe, even the dominance of our species, all of it could be rewritten by a single strike. That is the uneasy truth we live with, and the reason why humanity's gaze must never turn too far from the sky. Because as history has shown us time and again, survival on Earth doesn't just depend on what happens below our feet. It also depends on what's hurtling toward us from the dark, infinite void above. When we look back across billions of years of Earth's history, the most powerful forces that shaped the planet were always natural. Volcanoes, shifting tectonic plates, asteroid strikes, and the steady pull of the sun and moon. But in the blink of an eye, on a geological scale, one species has risen to rival those cosmic and planetary powers. That species is us. Humanity has become a geological force, altering landscapes, redirecting rivers, changing the chemistry of the atmosphere and oceans, and even leaving behind traces that future civilizations, if they exist, will find buried in the rock. Scientists now speak of a new epoch, the Anthropocene, the age of humans. And whether we like it or not, our influence on the Earth is undeniable. What's at stake is whether this influence will sustain life or accelerate its decline. The first signs of our impact appeared with fire. When early humans learned to control flames, they didn't just cook food, they began reshaping ecosystems. Entire forests were burned to clear land for hunting, altering habitats for countless species. Later, agriculture brought even more profound changes. The domestication of plants and animals allowed civilizations to grow, but it also meant deforestation, soil depletion, and the first large-scale shifts in land use. For thousands of years, these changes seemed small compared to the vastness of Earth. But as populations grew and technology advanced, the pace quickened. By the time the Industrial Revolution struck, humanity had begun altering the planet in ways that could no longer be considered temporary or local. The burning of coal, oil, and natural gas released energy that powered machines, factories, and cities. But it also pumped billions of tons of carbon dioxide into the air. At first, the atmosphere absorbed it without notice. But as emissions grew, the delicate balance of gases began to tilt. The greenhouse effect, which makes Earth habitable by trapping heat, began to amplify. The result is a warming planet where glaciers retreat, seas rise, and weather grows more chaotic with every passing decade. Never before in Earth's history has one species altered the climate so rapidly. Even mass volcanic eruptions, which once plunged the planet into icy winters or blazing summers, acted more slowly compared to what humans have unleashed in just 2 centuries. But climate change is only one piece of the puzzle. Humanity has transformed the surface of Earth itself. Rivers like the Nile, the Colorado, and the Yangtze have been dammed, redirected, or drained, turning natural flows into controlled systems designed for our needs. Forests that once stretched endlessly across continents have been cut, logged, and burned, leaving fragments of wilderness where thriving ecosystems once stood. Grasslands have been converted into farmland, wetlands drained into suburbs, and entire coastlines reshaped by cities, ports, and industry. The Earth from space no longer looks like the untouched blue planet of ancient times. It bears the fingerprints of roads, fields, and sprawling megacities that glitter at night like constellations on the ground. The oceans, too, have felt our hand. Overfishing has stripped away species that once dominated the seas, while plastic pollution has infiltrated every level of the food chain. Microplastics now float in the water we drink, the fish we eat, and even the air we breathe. Chemicals from fertilizers and industry have created dead zones where oxygen levels plummet and life struggles to survive. And yet, the oceans also absorb much of the carbon dioxide we release, buffering us from the worst impacts of our own emissions. But this comes at a cost. The water becomes more acidic, threatening coral reefs and shell-forming creatures that anchor marine ecosystem. Humanity's mark on the seas is as deep as it is on land. Perhaps one of the most striking consequences of human activity is the loss of biodiversity. Earth has gone through 5 mass extinctions before, each wiping out a huge percentage of life. Now scientists warn we are driving a 6th extinction, this time caused not by asteroids or volcanic eruptions, but by deforestation, pollution, hunting, and climate change. Species vanish at rates thousands of times faster than normal, and with each loss, ecosystems become weaker. From the great herds of elephants reduced to pockets of survivors, to bees and insects declining silently but critically, humanity's hunger for expansion and consumption has reshaped the web of life that sustained the planet for millions of years. Our technological footprint adds another strange chapter to Earth's history. Future geologists, millions of years from now, might not find the fossils of dinosaurs or mammoths, but they will find ours. They'll uncover layers of rock filled with plastics, aluminum, concrete, and radioactive isotopes from nuclear tests. They'll see a geological record scarred by mines that hollowed out mountains, tunnels that pierced the crust, and cities that sprawled into desert. In essence, humanity has already written itself into the stone layers of Earth's history. We have become a force comparable to tectonics or meteor strikes, but one powered by machines and choices rather than nature alone. Yet the story isn't only about destruction. Humans also have the unique ability to reflect, adapt and change. We've built conservation programs to save endangered species, protected vast stretches of wilderness, and begun shifting toward renewable energy sources like wind and solar. Some scientists dream of rewilding landscapes, bringing back lost ecosystems, and even resurrecting extinct species with genetic technology. Others imagine geoengineering projects to cool the planet or capture carbon from the atmosphere. These efforts show that while we've caused immense damage, we also hold the tools to steer Earth's future in a better direction. But the question remains, will we act fast enough and on a scale large enough to matter? What makes humanity's impact so shocking is its speed. The dinosaurs ruled for 60 million years without reshaping the climate the way we have in just 200. Civilizations rose and fell for thousands of years without leaving behind more than ruins and pottery shards. But in a single century, we've transformed the very systems that regulate life on Earth. We've entered an age where one species has the power to determine the fate of countless others, and perhaps the fate of the planet itself. That is both a terrifying and awe-inspiring reality. At the heart of this transformation lies a paradox. Humanity's greatest strength is its intelligence, but also its greatest threat. We are able to harness the energy of the atom, map the genome, and even peer into the stars. Yet that same power leads to weapons of mass destruction, ecological collapse, and unsustainable consumption. The story of human impact is not finished. It's unfolding in real time. Every policy, every innovation, every choice we make adds a new chapter. So as we stand on this edge of history, Earth bears the marks of our presence in every corner, from the melting glaciers of the poles to the deserts expanding across Africa, from the skyscrapers rising into the sky to the garbage patches floating in the Pacific. We are not separate from the planet. We are shaping it with every step, every invention, and every mistake. The question is whether we will continue down a path of destruction, or whether we will find a way to harmonize with the very Earth that made our existence possible. Because one thing is certain, Earth will survive. It has endured asteroid strikes, ice ages, and mass extinctions. But whether humanity survives with it, that is a decision only we can make. If Earth's past teaches us resilience and its present shows us fragility, then its future presents both a warning and an invitation. Humanity stands at a crossroads unlike any other in history. For billions of years, the planet evolved under the slow hand of geology and the violent interruptions of cosmic impacts. But now, for the first time, the fate of Earth's surface, and perhaps life itself, depends not only on natural forces, but on the choices of one species. What lies ahead is a story unwritten, with chapters that could tell of catastrophe, adaptation, or even transcendence. And it begins with the question, will humanity learn to live within the boundaries of a planet that has limits, or will it test those limits until they break? The first challenge facing Earth's future is climate. Already, global temperatures rise each year, glaciers shrink, and seas creep higher onto coasts. If current trends continue unchecked, entire cities could be drowned beneath the waves by the end of this century. Miami, Jakarta, Shanghai, and even parts of New York could become memories under the water. Rising seas would not just erase coastlines, they would displace hundreds of millions of people, forcing migrations on a scale the world has never seen. This is not science fiction, it is a projection built from today's data. The choices humanity makes now in terms of energy, industry, and conservation will determine whether the future Earth is a thriving home or a hostile environment. But climate change is not the only looming transformation. As the population grows and resources become strained, humanity must confront the limits of consumption. Forests that took centuries to grow are cut down in days. Fossil fuels that formed over millions of years are burned in decades. If this trajectory continues, Earth may enter a phase of collapse, not because the planet itself is fragile, but because ecosystems cannot replenish what is being taken. Yet within this crisis lies a strange form of opportunity. Humans are uniquely capable of innovation, and the technologies of tomorrow may not only reduce harm, but actually restore what was lost. Imagine reforested continents, oceans cleared of plastic, and air scrubbed clean of excess carbon. The tools exist. The question is whether the will does. Looking further ahead, humanity may not limit itself to Earth at all. The same intelligence that allowed us to split atoms and decode DNA also drives us to look beyond the planet. Colonies on Mars or bases on the Moon could one day serve as insurance policies for human survival. But even as we dream of other worlds, we must remember this. Earth is the only planet we know that is already perfectly suited for life. To abandon it would be not just foolish but tragic. Future generations may live among the stars, but Earth will always be our first and most vital home. Its survival is tied to ours, and ours to it. There are also deeper, stranger possibilities in Earth's future, ones that move beyond human control. The planet itself is not static. The continents still drift, slowly but surely, toward new configurations. In 250 million years, scientists predict a new supercontinent will form, reshaping oceans, climates, and ecosystems. Earth will survive such changes, as it always has, but whether humanity or its descendants will still be here to witness it is unknown. Even the sun itself holds a destiny for Earth. In about 1 billion years, as the sun grows hotter, oceans may boil away, rendering the planet inhospitable. And in 5 billion years, when the sun swells into a red giant, Earth may be consumed entirely. In that distant future, survival will require humanity, or whatever life evolves from it, to have left the cradle of this planet. But before those cosmic timescales, there are nearer-term mysteries to face. Could Earth experience another asteroid strike large enough to end civilizations? Statistically, the answer is yes, though when remains uncertain. Could supervolcanoes erupt, blanketing the sky in ash, and plunging the world into years of winter? History says they already have, and likely will again. Could the magnetic field powered by Earth's molten core falter and expose us to solar radiation? Scientists debate this, noting that magnetic reversals have happened before. These are natural forces beyond our control, reminders that even in an age where humanity seems powerful, the planet still answers to larger rhythms of the cosmos. Yet the greatest unknown in Earth's future may not be geology or space, it may be us. Will humanity act collectively or remain divided by borders, politics, and short-term interests? Will technology become our salvation, or will it accelerate our downfall? Will we learn to see ourselves as caretakers of a living planet, or continue to treat it as a resource to be consumed until nothing remains? The future Earth reflects not just scientific probabilities, but moral choices, and that may be the most radical shift of all. The idea that the planet's fate is no longer entirely natural, but entangled with human ethics and vision. There is, however, one certainty. Earth itself will endure. It has been shattered by impacts, suffocated by ice, scorched by lava, and yet life found a way to adapt, survive, and even flourish. The planet has recovered from every disaster, though often at the cost of entire species. If humanity disappears tomorrow, the forests will reclaim cities, rivers will carve new paths, and life will continue in forms we cannot imagine. The story of Earth does not depend on us, but our story depends entirely on Earth. So when we look toward the future, we should see both danger and possibility. Danger, because our current path threatens to destabilize the systems that keep life in balance. Possibility, because never before has a species had the knowledge and tools to not only predict its own future, but shape it. We stand at the threshold of either collapse or renewal. The Earth of tomorrow could be scarred, barren, and hostile, or it could be revitalized, green, and thriving, depending on how we act today. And perhaps that is the most mysterious truth of all. The Earth's future is not written in stone or dictated by the stars. It is written in the hands of humanity. For billions of years, Earth was guided only by natural law. But now, for the first time, a species has taken the pen. The question is, what story we will write? Whether it will be one of destruction or one of stewardship, one of endings or one of new beginnings. Because while the universe is vast and indifferent, this planet remains a rare jewel, fragile and resilient, ancient yet alive. The future of Earth is also the future of us, and it will be defined not by what happens to us, but by what we choose to do. From the first sparks of its formation out of cosmic dust to the thriving blue and green jewel we know today, Earth has never stopped evolving. Its landscapes have been carved by fire and ice, its skies reshaped by meteors and volcanoes, its oceans deepened by tectonic shifts, and its life transformed by extinctions and rebirths. For billions of years, Earth was a stage without human actors. Then, in the briefest blink of cosmic time, humanity appeared, bringing intelligence, curiosity, and the power to alter the planet on a scale once reserved for natural catastrophes. Now, as we look to the future, we must confront a truth both humbling and empowering. Earth will continue with or without us, but our survival and the survival of countless species depends on whether we can learn to live in balance with it. The story of Earth is not just about rocks and oceans, it is about resilience. Time and again, the planet has endured mass extinctions, cataclysms, and ice ages, only to regenerate itself in new and astonishing forms. Dinosaurs once ruled the continents before vanishing, making way for mammals to rise. Supercontinents have formed and broken apart, reshaping climates and habitats. Even when over 90% of life was wiped out in the Great Dying, Earth's story did not end. It began again, transformed. This resilience should give us hope, but it also offers a warning. Earth does not need us to continue. If humanity fails, the forests will return, seas will adjust, and evolution will craft new forms of life. The question is not whether Earth will survive, but whether we will. Our modern world has placed us in an unprecedented position. For the first time, a species is not merely subject to Earth's cycles, but capable of altering them. The carbon we release warms the atmosphere. The plastics we discard infiltrate oceans and soil. The forests we cut down weaken the lungs of the planet. Unlike asteroids or supervolcanoes, these changes are deliberate, consequences of human choices, and yet, within that reality lies the possibility of a miracle. Because if we are powerful enough to damage Earth, we are powerful enough to heal it. Renewable energy, reforestation, and sustainable living are not just dreams, they are lifelines. The tools exist to reshape our relationship with the planet. What remains uncertain is whether we will embrace them in time. But Earth's future is not only about crisis, it is about imagination. Humanity has always looked beyond the horizon, and in this age, the horizons include the stars. Colonizing Mars or building bases on the moon are no longer fantasies but emerging possibilities. Yet even as we dream of other worlds, we must never forget that Earth is unique, a planet already rich in air, water, and ecosystems. It is the cradle of our species, the only place in the universe we know for certain can sustain us. To neglect it while chasing distant planets would be the greatest mistake of all. And beyond survival lies a deeper truth. Earth is not just a resource or a home, it is a living archive of memory, a place where every stone, fossil, and species carries the echoes of ages past. To understand Earth is to understand ourselves, our origins, our fragility, and our potential. Protecting Earth is not simply about preventing collapse, it is about honoring the story that has unfolded for billions of years and ensuring that the story continues with us in it. So as we stand on the threshold of the future, we must ask, what story will we write next? Will it be one of destruction, where greed and neglect bring an end to civilization? Or will it be one of renewal, where humanity becomes a caretaker of the planet rather than its conqueror? The choice remains ours, written not in the stars but in the decisions we make every day, because, in the end, Earth is more than just a planet. It is a rare miracle in an endless universe, a fragile sanctuary where life has not only endured but flourished. It is our first home, and perhaps our only true one. And though Earth's story will outlast us, our greatest achievement would be to ensure that humanity becomes a chapter not of ruin, but of harmony. The future of Earth is still unwritten. The pen lies in our hands. The question is whether we will craft a story worth remembering, or vanish as just another forgotten experiment in the planet's eternal tale.